All right, everyone, buckle up because we're diving deep, really deep, into the engine room of online shopping. This is the system that keeps those add cart buttons hunging, even when there are, like, millions of us all shopping at once.
Amazon DynamoDB.
Exactly. We're talking trillions of requests every single day. It's like Black Friday, but on steroids, and it's happening every single day.
Every single.
Now, you might be thinking, okay, but my project's not exactly Amazon size, and you're probably right. But here's the thing. This deep dive isn't just about handling massive, mind-boggling scale. It's about building systems that can handle literally anything. Unexpected spikes, crazy growth spurts, you name it. That's DynamoDB's superpower, and honestly, those are lessons that anyone, and I mean anyone, building applications can learn from. So to really wrap our heads around just how wild DynamoDB is, we need to rewind a bit. Back to the early days of Amazon. Picture it. A simpler website, but with a surprisingly hairy problem. How in the world do you keep track of everyone's shopping carts when your site is growing faster than faster than anything you've ever seen?
That's where Dynamo comes in. Not DynamoDB, just Dynamo. This was way before database as a service was even a thing.
The stone ages of the internet.
Basically. Dynamo, it was revolutionary, but imagine this. You got the keys to this super fast car, but no roads to drive it on. You're responsible for building those roads yourself. Powerful. Absolutely. Chaotic. You bet.
Okay, yeah, I see why that wouldn't have lasted very long. So how did they bridge that gap from, like, roadless supercars to something a little more, manageable?
Well, as an evolution, right? Their first attempt was SimpleDB. Think of it as Amazon dipping their toes into the database as a service world.
So like those little rental cars at the airport?
Yeah.
Easy to use, gets the job done, but not exactly built for a high-speed chase.
Perfect analogy. SimpleDB was great for ease of use, but it had its limits. Couldn't handle huge amounts of data or traffic.
Not quite ready for the Autobahn.
Not even close.
Yeah.
And that is where DynamoDB steps onto the scene. They took that raw power of Dynamo, that ease of use of SimpleDB, sprinkled in a decade of being battle-tested by Amazon's own insane growth. And boom, DynamoDB.
Okay, that's some serious pedigree right there. So let's pop the hood on this thing. I keep hearing about this table in DynamoDB, but we're not talking about, like, your grandma's dining room table here, right?
Definitely not. Imagine a library, a gigantic, constantly expanding library. But instead of books, you've got items, and those items are made up of attributes.
So, like, each item is, what, a file folder, and the attributes are all the little bits of info inside.
Exactly. And to keep everything organized, every single item gets a primary key. Think of it like a supercharged index card that tells DynamoDB exactly where to find what it's looking for.
So it's like having a personal librarian who knows the exact location of every single book in this massive, ever-growing library.
You got it. But it gets even cooler. To make things super efficient, DynamoDB takes these massive tables and divides them into smaller chunks called, wait for it, partitions.
Okay, so if the table is the library, then the partitions are like different wings, each dedicated to a certain category of book.
You're getting it. That way, when DynamoDB needs information, it doesn't have to waste time searching the entire library. Just the relevant wing makes things lightning fast.
Okay, that makes sense. But I've got to ask, why does all this partitioning business even matter for someone building an app? Is this just like a neat organizational trick, or is there more to it?
It's the key to handling those massive Black Friday-level traffic spikes we were talking about. Think about it like adding extra lanes to a highway during rush hour. Things keep moving smoothly, no matter how many cars pile on. As your data grows, DynamoDB just adds more servers and partitions, spreading out the workload automatically. You don't have to lift a finger.
Seamless scaling. I like the sound of that. But here's the million-dollar question, and it's one I'm sure a lot of people are wondering. How does DynamoDB actually know how much highway to build in the first place? Isn't there a risk of building way too much, or even worse, not enough?
You're absolutely right. It's a balancing act. Back in the day, users had to guess how much capacity their table would need.
So what happened?
Well, they ended up either wasting a ton of resources on capacity they didn't need, or they hit a wall when their app took off. And suddenly, bam, not enough capacity. Like trying to squeeze everyone into a clown car.
Yikes. Sound like a recipe for disaster. I bet that led to some pretty frantic calls to customer support.
You can bet on that. So the brilliant minds behind DynamoDB, they went back to the drawing board and came up with some seriously clever solutions. First up, bursting. Think of it like a nitrous boost for your database.
Adding a turbo button to my app, I like it.
Right. It gives your partitions this short burst of extra power to deal with those sudden spikes.
Okay, that makes sense for those flash in the pan moments, but what about those times when it's not a quick burst, but like a steady climb?
Hmm.
Say your app goes viral and you've got this constant increase in traffic. What happens then?
Then adaptive capacity steps in.
Yeah.
DynamoDB, it's always watching the traffic, right?
Mhm.
And it adjusts capacity on the fly.
So it's like a self-driving car for my database, changing lanes, speeding up, slowing down, whatever it takes.
Exactly. Pretty slick, right?
Definitely. But if it's still reacting to traffic, is there still a chance of hitting those like digital traffic jams, slowdowns, delays, all that fun stuff?
Well, you're right. It wasn't foolproof.
Yep.
The real game changer, the real aha moment was global admission control.
Okay, now you're just using fancy words to sound smart.
Maybe a little. But seriously, picture this. An air traffic control system, but for your database.
Okay, I'm listening.
It sees all the traffic,
Right.
Like a bird's eye view, and makes sure everything's distributed evenly across all the servers. No more bottlenecks, no more overload. It just flows.
Smooth sailing, no matter the weather. That's impressive. But let's talk about something that honestly keeps every developer up at night. What happens when things go wrong? And I'm not talking about if, but when. Hardware fails, software has bugs. It's the nature of the beast, right?
Tell me about it. And honestly, that's where DynamoDB truly shines. It's like they built this system with Murphy's Law in mind. Multiple layers of defense, all designed to keep your data safe, even when the unexpected hits the fan.
Okay, you're gonna have to walk me off the ledge here. How do they actually pull that off?
First things first, replication. Your data isn't just sitting on one server, crossing its fingers, hoping for the best. It's mirrored across multiple servers, and to top it off, it's backed up to Amazon S3,
And S3.
designed for 11 nines of durability.
11 nines. Is that even a real thing?
It's a thing. It basically means your data is about as safe as it can be. We're talking protected from almost anything levels of safe.
Okay, so even if, like, a meteor takes out a data center, my cat videos are safe? Because that's reassuring.
Your cat videos, your family photos, your super secret project you're working on, it's all protected. But data can go sideways in other ways too. Like those old floppy disks that just stop working one day.
Data corruption, the dreaded digital bit rot, it's a real thing.
And DynamoDB's got you covered there too. They use these things called checksums. Think of them like tiny little digital fingerprints that verify your data every step of the way.
Okay, so it's like having a detective constantly checking for signs of tampering.
Exactly. And if something seems off, DynamoDB automatically repairs or restores your data from those super durable backups we were talking about.
A self-healing database.
Yeah.
Pretty cool. But we've got backups, checksums, it's like Fort Knox for data. With all these safeguards, this whole system must be incredibly complex to build and maintain. How do they make sure it all actually works like it's supposed to?
Now, that is where things get interesting. DynamoDB, they use something called formal methods, particularly a language called TLA+.
Formal dot methods, you mean like with tuxedos and long downs?
Not quite. We're talking about using math to prove that their systems work correctly.
Wait, they use math to prove their code works? That's a thing.
Oh, it's a thing. It's like having a team of superpowered mathematicians checking every line of code, making sure it behaves perfectly, even in the craziest situations. They even do this thing called failure injection testing.
Failure injection testing sounds intense.
It's like it sounds. They deliberately introduce failures into the system.
They break things on purpose.
In a controlled way, of course. By doing this, they figure out how the system will react in real-world situations and fine-tune those self-healing mechanisms we were talking about. This dedication to testing, it's a big part of what makes DynamoDB so reliable.
I'm convinced these DynamoDB engineers are like the superheroes of the database world. But even superheroes need a little help sometimes, right? What happens if something does go wrong and you need to restore your data?
Great question. DynamoDB has you covered there too. They've got these on-demand backups, like taking a snapshot of your data whenever you need it. Plus, they have this really cool feature called point-in-time recovery.
Point-in-time recovery, so like time travel, but for your data.
You got it. It's like a DVR for your database. You can literally rewind to any point in the past 35 days.
35 days worth of do-overs? That's incredible. But let's zoom out for a second. We've been diving deep into how DynamoDB handles all these behind-the-scenes challenges, but what about real-world performance? When someone's browsing on their phone, waiting for a page to load, they don't see all this complex stuff happening in the background. They just want things to be fast. So how does DynamoDB handle those huge traffic spikes while still delivering that super fast, seamless experience we've all come to expect?
Well, remember those partitions we talked about earlier? They're not just for storage. They're actually the key to DynamoDB's impressive performance.
So it's like having a bunch of chefs in the kitchen all working on different parts of the meal at the same time instead of just one chef trying to do it all.
Exactly. Things move way faster when you can divide and conquer.
Mhm.
But DynamoDB doesn't just divide up the work, it's also smart about where that work happens. They use this system called consistent hashing to make sure all those partitions are spread out nicely across all the servers.
Consistent hashing. Okay, isn't that the thing where it's like assigning servers to data based on their position on this imaginary ring? I remember reading about that, but it kind of sounded like dot magic, to be honest.
It's not magic, but it's definitely clever. Imagine a dartboard, right?
Oh.
But instead of numbers, each section represents one of your servers. When you add data to DynamoDB, this consistent hashing algorithm, it throws a dart at the dartboard. Wherever it lands, that's the server where that data lives.
Ah, I get it. So even if you're adding servers or taking them away, the data gets redistributed without causing a huge mess.
Exactly. It's all about keeping things balanced, making sure no single server is overworked. That's how they keep those performance bottlenecks at bay. But wait, there's more. DynamoDB also uses caching. It's like having shortcuts for information you need really often.
Cache it, it's like keeping your favorite spices within arm's reach instead of digging through the back of the pantry every time you cook, right?
Perfect analogy. DynamoDB actually uses multiple levels of caching to keep frequently accessed data close to the application so it doesn't have to make a trip all the way back to the main database every single time. It saves a ton of time.
Makes sense. But we've talked about a lot of different parts here. Partitions, caching, all that good stuff. How does it all actually fit together, especially across multiple data centers? I mean, communication between all those moving parts has got to be pretty complicated.
And that is where DynamoDB's networking infrastructure comes in.
Mm-hmm.
Think of it like a super fast, super reliable train system connecting all those different parts of the library we were talking about earlier, making sure those books get delivered right on time, every time.
So it's not enough to just have fast servers. You also need lightning fast connections between them.
You got it. It's like a Formula One race car with a supercharged internet connection speed, A&D reliability. That's the name of the game. But even with the most amazing tech in the world, we can't forget about the human element. I mean, building and maintaining a system this complex that takes a seriously talented team working behind the scenes.
So it's not just about automation. There are real people keeping an eye on things, making sure all those servers are playing nicely together.
Oh, absolutely. We're talking experts in distributed systems, networking, security, the whole shebang, all working together. And they're always learning, always adapting, always pushing the limits of what's possible with database technology. And speaking of pushing limits, we have to talk about one of the coolest things about DynamoDB, global tables.
Okay, now we're talking. World domination, one database at a time.
Not quite, but close. It's like taking everything we've discussed, the crazy scalability, the lightning-fast performance, the Fort Knox-level durability, and cloning it all over the planet.
So whether your users are in London, Tokyo, or like on the moon?
Well, not the moon yet.
Okay, fair enough. But the point is, everyone has that same super fast experience no matter where they are in the world.
Exactly. It's like magic, but instead of spells, it's really, really clever engineering.
Yeah.
Global tables are a game changer for applications that have users spread out all over the world.
It all sounds great, but with all that data zipping around the globe, how do they actually keep it all synchronized? Seems like a recipe for disaster if you're not careful.
You're right, it could be a recipe for disaster, but luckily, DynamoDB has these things called consistency models.
Consistency models.
Basically, they give developers the ability to choose exactly how in sync they need their data to be, balancing things like speed with making sure everyone sees the most up-to-date information.
So like different levels of keeping it real.
Exactly. You've got your strongly consistent reads, which are like you're getting the absolute latest news update no matter what. And then there's eventually consistent reads, which are more like checking your social media feed. You might not see every single update right this second, but it'll catch up eventually.
And I'm guessing the eventually consistent option is a bit more forgiving when you've got data bouncing between continents.
You got it. For a lot of applications, especially those with users all over the world, those tiny little delays don't even matter. It's all about finding that right balance, right?
Yeah.
Absolute up to the millisecond accuracy versus making sure things run without a hitch globally.
Makes sense.
Oh.
But let's not forget about the elephant in the room, or should I say the security guard in the server room. We've talked about performance, scalability, all that good stuff. But we're talking about sensitive information here, people. How does DynamoDB handle security?
Okay, so first of all, security is huge EE for DynamoDB, like top priority. They have this multi-layered approach, tighter than a drum.
Okay, walk me through it.
For starters, all data in DynamoDB is encrypted at rest, automatically. Think of it like having a digital lockbox for your data.
Got it. So even if someone managed to break into the physical servers, they wouldn't be able to make sense of the data without the key. But what about when that data is moving between servers?
That's where transport encryption swoops in. All communication with DynamoDB uses HTTPS, the same stuff that keeps your online banking secure. It's like sending your data in an armored truck instead of a postcard.
Love that visual. But it doesn't end there, does it? DynamoDB has more security tricks up its sleeve.
Oh, you know it. It works hand in hand with AWS Identity and Access Management, or IAM for short. Think of IAM as that super strict bouncer at the club, only letting in the folks who are on the list.
So I can control who gets to see what and what they can do with it.
Precisely. You decide who gets the VIP access and who's stuck with the guest list. And for those who want even more control, there's always client-side encryption.
Client-side encryption. Now we're talking next level. So I'm encrypting the data on my end before it even gets sent to DynamoDB.
Exactly. Talk about peace of mind. It means that not even Amazon can peek at your data without the key. It's like you have the only copy.
Okay, that's impressive. But with all these layers of security, it's got to be a nightmare to manage, right?
You'd think so, but DynamoDB makes it surprisingly straightforward. They've simplified key management, provided detailed audit logs.
Yeah.
You can track everything that's happening with your data. Think of it like having a security camera for your database. You can see exactly who accessed what and when.
Okay, now that's what I call peace of mind. But time for a reality check. All this power, all this security, it can't be cheap. How does DynamoDB handle cost? Because let's be real, building the world's most resilient database probably isn't easy on the wallet.
You're not wrong. Cost is definitely a factor.
Yeah.
But here's the good news. DynamoDB gives you options. They have this thing called on-demand capacity mode. Basically, you only pay for what you use.
Like my electricity bill.
Exactly.
Yeah.
It's perfect for those applications that have unpredictable workloads. You know, like if you're running a flash sale or something and traffic is going to be all over the place.
So no more overpaying for capacity you're not even using. I like it. But what about apps that have more consistent traffic patterns?
They have an option for that too. It's called provisioned capacity. You reserve a set amount of resources up front and you get a discount.
Wholesale pricing for data. Love it. Okay, so it's all about choosing the model that fits your needs. But earlier we were talking about global secondary indexes. Do those have any impact on cost?
Actually, they can be a huge help. A well-designed index can make your main database more efficient, and that translates to cost savings.
So indexes are like those shortcuts again, but this time they're saving me money too.
You got it. By storing and accessing only the data you need for specific queries, you can shrink your overall costs. It's about being smart and efficient.
Love it. Working smarter, not harder. That should be our motto. Okay, we've covered so much ground today, from the nuts and bolts of how DynamoDB actually works, to its global reach, to those Fort Knox level security measures, and even some tips on how to keep those costs under control. It's been quite a journey. Any final thoughts?
I think the biggest takeaway here is that the principles behind DynamoDB, they can be applied at any scale.
So even if you're not building the next Amazon, there's still a lot to learn from all this.
Absolutely.
Yeah.
No matter what you're building, thinking about things like partitioning, caching, performance optimization, those are all valuable lessons that'll serve you well.
It's like learning how to cook, right?
Yeah.
You start with the basics, and then once you've mastered those techniques, you can create just about anything.
Exactly. So be curious, experiment, push the boundaries a little bit. You never know what amazing things you might create.
Well said. And to everyone listening, thank you so much for joining us on this deep dive into the incredible world of Amazon DynamoDB. It's been a wild ride. We've just scratched the surface, really. There's a ton of information out there, documentation, tutorials, blog posts, you name it. If you want to learn more, go explore, experiment, and see what you can build. Until next time.
Happy coding.